In question number 10, a sound emitting source S is moving with constant velocity. Two stationary observers A and B are in the line of motion of source. Then, apparent frequency, wavelength, and speed of sound observed by observer A are Fa, lambda A and Va respectively, and those observed by observer B are Fb, lambda B and Vb respectively. Then, so from Doppler's effect, we know that the apparent frequency f dash is given by f naught, that is the original frequency, into velocity of sound in air plus minus velocity of observer divided by velocity of sound in air plus minus velocity of source. So in this case, the source is moving towards B. So as the source is moving towards B, the apparent frequency heard by observer B will increase. So the frequency of B is greater than the frequency heard by observer A. So Fb is greater than Fa. Since the frequency is increasing, so the wavelength will decrease. So in the direction of the source, the wavelength decreases. So the apparent wavelength for observer B is less than the apparent wavelength for observer A. So option B is correct and option A is also correct. Now the apparent velocity of sound for both the observer will remain same. So option D is correct and option C is wrong. So the correct answer for question number 10 are option A, B and D. Let's move to question number 11. In question number 11, a particle moves along x-axis according to the displacement equation x is equal to a sine square omega t minus pi by 4. So sine square theta can be written as 1 minus cos 2 theta divided by 2. So this equation x can be written as a by 2 into 1 minus cos 2 theta. So this can be written as 2 omega t minus pi by 2. Now if I calculate the velocity v, it comes out to be a omega into sine 2 omega t minus pi by 2. And if I calculate the acceleration a, this comes out to be minus 2a omega square cos 2 omega t minus pi by 2. So let's check the options. So the time period is given by 2 pi by omega and the value of omega is 2 omega here. So it equal to pi by omega. So option A is correct. In option B, amplitude of oscillation is a by 2. So its amplitude is a by 2 because the coefficient of cos function is a by 2. So option B is also correct. In option C, velocity of particle at t equal to pi by 4 omega is 0. So at t equal to pi by 4 omega, it is equal to pi by 2. So pi by 2 minus pi by 2 is 0. So the velocity becomes 0. So option C is also correct. In option D, the acceleration of particle at t equal to pi by 4 omega. So if I substitute the value of t is equal to pi by 4 omega, this becomes 0. And this comes out to be minus 2 times a omega square. So option D is wrong. So the correct answer for question number 11 are option A, B and C. Let's move to question number 12. In question number 12, a block of mass m is attached at one end of a vertical unstretched spring of a spring constant K, whose other end is attached with ceiling. The block is now released. Then we have to check the validity of given options. So let's analyze the situation. Suppose this is a spring and this spring is in natural length at this position and the block is connected to this spring at this position and the block is released. So due to the gravitational force acting on the block, let the maximum displacement of this block up to this position. So this is the x maximum. So if I apply the work energy theorem, then the work done by gravitational force is mg into x maximum and the work done by spring is minus half k into x maximum square must be equal to 0 because change in kinetic energy is 0. So from here the value of x maximum comes out to be 2 times mg by k. Let's check the options. The amplitude of oscillation will be 2 mg by k. So in between there is the mean position where the net force is 0. So this separation must be equal to this separation. So if I take as my amplitude, then 2a is equal to x maximum. So the amplitude is equal to mg by k. So option A is wrong. In option B, time period of oscillation will be 2 pi under root m by k. For a spring block system, this is the time period. So option B is correct. Maximum force on the ceiling. So maximum force on the ceiling occurs when the extension in the spring is maximum. So that is k into x maximum, and the value of x maximum is mg by k. So it is equal to 2 mg. So option C is correct. In option D, maximum kinetic energy of the block will be. So maximum kinetic energy of the block is possible when the block is at the mean position. So that can be written as half into m into velocity at mean position is a omega. So a omega is square. So amplitude is mg by k, it's a square, into omega square is k by m. So on solving, it comes out to be m square g square by 2k. So option D is also correct. So correct answer for question number 12 are option B, C and D. Let's move to question number 13. In question number 13, 1 mole of an ideal monatomic gas is expanded according to law P is equal to kV, where P is pressure, V is volume and K is constant. If the initial volume and temperature of gas are V0 and T0 respectively, and final volume of gas is 3V0, then we have to check the validity of given options. So the process equation is P into V raised to the power minus 1 is equal to constant. So if I compare with the polytropic process equation, PV ki power x is equal to constant, then the value of x is equal to minus 1. So the molar heat capacity of this process can be given as C is equal to CV. Since the gas is monoatomic, so this can be written as 3R by 2 plus R divided by 1 minus x. So 1 minus of minus 1, so this will be plus 1. So this comes out to be 2R. Now the value of C is 2R. So option C is correct. Now in order to find out the value of change in internal energy, work done and amount of heat, further the process equation is given as P is equal to kV. So we can say that P by V is equal to constant. So P2 by V2 is equal to P1 by V1. So we can say that V2 is 3V0. So P2 becomes 3P0 if initial pressure P1 is P0. And from the ideal gas equation, we know that PV is equal to nRT and N is constant. So PV by T is equal to constant, or we can say that P2 V2 by T2 is equal to P1 V1 by T1. So we know that P2 is 3P0, V2 is 3V0, and we have to find out T2. So this is equal to V1 is V0 and T1 is T0. So on solving this equation, the value of T2 comes out to be 9 T0, or change in temperature delta T comes out to be 8 T0. Now let's check option A. Change in internal energy of the gas is. So change in internal energy of the gas delta U can be written as N CV dt. So N is 1, CV is 3R by 2 for the monatomic gas, into dt is 8 T0. So it comes out to be 12 R T0. So option A is correct. If I check option D, amount of heat taken by the gas. So delta Q is equal to NC dt. So N is 1, C is 2R and dt is 8 T0. So it is equal to 16 R T0. So option D is also correct. And if I calculate the work done from the first law of thermodynamics, delta Q 16 R T0 is equal to delta U 12 R T0 plus work done by the gas. So the work done by the gas comes out to be 4 R T0. So option B is wrong. So the correct answer for question number 13 are option A, C and D. Let's move to question number 14. In question number 14, a uniform wire of mass m and length L is suspended vertically with one end fixed to the ceiling. Now, a wave pulse generated at lower end of wire. Then we have to check the validity of given options. So, if I analyze the situation, suppose this is a ceiling and this is a wire whose mass is m and length is L. So if I consider an element at a distance x from the bottommost position of length dx, then the tension acting on this element is let T. Then the value of T can be written as m by L into x. This is the mass of this considered segment into g. So the velocity at this position can be written as v is equal to under root T by mu. So the value of T is this, that is m by L into x into g divided by mu, and the value of mu is m by L. So it comes out to be under root g into x. So if I square this equation, then it can be written as v square is equal to gx. So if I differentiate this, 2 into v dv by dx is equal to g, or the acceleration, that is v dv by dx is equal to g by 2. So in option B, it is given that the wave pulse moves upward with constant acceleration. So option B is correct. In option A, wave pulse moves upward with constant speed. So if I see the function of speed, then it is proportional to x, then it is proportional to under root of x. So option A is wrong and B is correct. Now in option C, the time taken by the pulse to reach the ceiling. Since the acceleration is constant and at x equal to 0, v is 0, so the displacement is L, that is equal to ut, that is 0 into t, plus half into a, that is g by 2, into t square. So if I solve, the value of t comes out to be 2 times under root L by g. So option C is correct. In option D, the velocity with which the pulse crosses the midpoint of wire is this much. So when the pulse reaches the midpoint, the displacement of the pulse is L by 2. So we can write v square is equal to initial velocity is 0 plus 2 times acceleration, that is g by 2 into L by 2. So it comes out to be under root of gl by 2. But in option D, it is given under root of gl by 2. So option D is wrong. So the correct answer for question number 14 are option B and C. Let's move to question number 15. In question number 15, a closed organ pipe is vibrating in its first overtone. So let's draw the diagram. This is closed organ pipe and it is vibrating in its first overtone. So this is the diagram of first overtone. So this point is displacement node, this point is displacement node, and this point is displacement antinode. Let's check the options. In option A, frequency is third harmonic. So this is my first harmonic and it is an odd multiple of first harmonic. So the next frequency is third harmonic. So option A is correct. Pressure node is formed at closed end. So at this closed end, pressure antinode is formed. So option B is wrong. In option C, near the open end, displacement antinode is formed. So option C is also wrong. In option D, pressure node is formed at a small distance outside the pipe. Since this is a point of displacement antinode, so the corresponding pressure is node, which form just outside the pipe. So option D is also correct. So the correct answer for question number 15 are option A and D. Let's move to question number 16.